In this video we're going to learn about second order partial derivatives. And in this video we're going to build off of the partial derivative video. So we're going to take all the second order partials for all the derivatives that we took in that last video. So remember, when we're looking for second order partials, we need to find f of xx, which means we take the derivative with respect to x and then with respect to x again. F yy, which is take the derivative with respect to y and then with respect to y again, and f of xy. So we're going to do this for each problem, and in this last one we're going to take the derivative with respect to x first and then with respect to y. In this first problem, f of x was equal to 6. So if we take the derivative again with respect to x, it's equal to 0. It's a constant, so it's going to be 0 regardless of what we're taking it with respect to. Same with fy of y. We're taking the derivative with respect to y, which we've done here, which is equal to 2, and now we're taking the derivative with respect to y again, so we get 0. And in this last one, we would be looking at f of x, and now doing it with respect to y. So the derivative of 6 is 0. So all of our second order partials in this one were equal to 0. Now let's look at another example where that won't be the case. So here we have f of x is equal to 2x divided by 7y plus 7. And I'm going to come down here and write that again so we don't have to fight to find it. F of x is equal to 2x divided by 7y plus 7. And then our f of y, which is right here, f of y is equal to, and I'm going to rewrite this. Oftentimes, if you rewrite it and make it an easier form, your derivative will be a little bit easier. So I'm going to distribute that negative 7, and I'm going to call this negative 7x squared minus 21 divided by 7y plus 7 squared. And now I want to find all of our partials. So in this first partial, f with respect to x with respect to x, so we're going to start with our f with respect to x, and we're going to take it with respect to x again. So we have the quotient rule, 7y plus 7 times the derivative of the numerator with respect to x, which is 2, minus 2x times the derivative of the denominator with respect to x. And 7y plus 7 is all treated like a constant, so it's 0, all divided by 7y plus 7 squared. And in this case, in our numerator on the right side, it goes to 0, and we have 7y plus 7 in the numerator and the denominator. So I can simplify this and say that this is equal to 2 divided by 7y plus 7. And now let's take a look at f of yy. So we're going to start with the partial with respect to y, and then we're going to take the derivative with respect to y. So we have 7y plus 7 squared times the derivative of the numerator with respect to y. And here, negative 7x squared minus 21 is all treated like a constant with respect to y, so it's times 0, minus negative 7x squared minus 21 times the derivative of the denominator with respect to y. And now we have the chain rule. So we have 2 times 7y plus 7, subtract 1 from the exponent, gives us 1, times the derivative of the inside with respect to y, which is equal to 7, all divided by 7y plus 7 to the 4th, squared squared. And now when we simplify, we get these terms on the left of the numerator go to 0, and then we have a 7y plus 7 here, which I'm going to cancel with one term here. So what I'm left with on the top is negative 14 times negative 7x squared minus 21, all divided by 7y plus 7 cubed. And now we want to take a look at f of xy. So in this problem, we're going to start with the derivative with respect to x. So we're going to start with 2x divided by 7y plus 7, and we're going to take it with respect to y. So we have the quotient rule still, so we have 7y plus 7 times the derivative of the numerator with respect to y, which is 0, minus 2x times the denominator with respect to y, which is 7, all divided by 7y plus 7 squared. And the left side of our numerator goes to 0, so we're left with negative 14x divided by 7y plus 7 squared. All right. In this next example, we have f of x is here, and then our final f of y is here. And here, what I'm going to do is I'm going to multiply this 4x times the parentheses so that I don't have to use the product rule here, and I can just use the power rule throughout this problem. Sometimes when you do partial derivatives, it's good to rewrite it in the simplest way possible to take the next derivative. So here I'm going to rewrite f of x equal to 10x plus y plus 4x cubed plus 4xy squared. And I'm going to write f of y as x plus 4x squared y plus 4y cubed. And now let's look at all the second order partials. So we have f of xx, which is equal to, so we start with f of x and we take the derivative with respect to x. So the first term is 10. Y is a constant, so it's 0. 4x cubed turns into 12x squared. And then we have 4xy squared. And remember, 4y squared is all constant, and the derivative of x is 1. So we're left with plus 4y squared. And we can simplify to 10 plus 12x squared plus 4y squared. And for f of y, we start with f of y, and then we take the derivative with respect to y. So the derivative of x is equal to 0. It's a constant. 4x squared y, and x squared and 4 are both our constants, and the derivative of y is 1. So we're left with 4x squared. And the derivative of 4y cubed with respect to y is 12y squared. So we get 4x squared plus 12y squared. And then when we do f of xy, we're going to start with f of x and take it with respect to y. So 10x goes to 0. The derivative of y is 1. 4x cubed is also all a constant and goes to 0. And then we have 4xy squared. So 4x is our constant, and the derivative of y is 2y, so we end up with 8xy, giving us 1 plus 8xy. Alright, in our last example, we have e to the xy was our original. F of x is y e to the xy, and f of y is x e to the xy. None of these need rewriting, so we'll get right into the second order partials. F of xx. So here we have the derivative of x, and we're going to take it with respect to x again. And remember, y is a constant, so we don't have the product rule here. We just have a constant multiple. So we're going to have y is going to carry down, and then we're going to do our rewrite of our exponential function, xy, and now we need to take the derivative of the exponent with respect to x. And remember, y is a constant, and x, the derivative of x is 1. So we end up with just another y, so times y, or y squared e to the xy. For our partial with respect to y again, we start with the partial with respect to y, and remember, again, x is a constant, so we have x times the rewrite of our exponential times the derivative of the exponent with respect to y, which is x. So in this case, we have x squared e to the xy. And then when we do the partial of x with respect to y, this is a little different now because y is now the variable we're taking with respect to, and it's not considered a constant anymore. So we have the product rule. So it's first, or y, times the derivative of the second term, which is the rewrite e to the xy, times the derivative of the exponent with respect to y, which is going to be x, plus the second term, e to the xy, times the derivative of the first term, which is y, with respect to y. So we have a 1 here. So we end up with xy e to the xy plus e to the xy. And those are our second order partials.